Welcome everyone. We are discussing problems of inverse circular function. Today I will discuss some problems of competitive exam of inverse circular functions. These are most important for exam and interesting too. So let us consider problem number 1. If A1, A2, A3, An are in a arithmetic progression having common difference D, then tan inverse D by 1 plus A1, A2. Product of two consecutive terms, tan inverse D by A2, A3 plus dot dot tan inverse D by 1 plus An minus 1 An equals. You have to find the value of this. Now what is the expression? Tan inverse. In each case, numerator is D, 1 plus A1, tan inverse D by 1 plus A2, A3. Finally, D by 1 plus An minus 1 into An. Now, it is given that A1, A2, A1, A2, A3, An are in A. Therefore, their difference A2 minus A1, A3 minus A2, difference of consecutive terms equals to common difference. So, by definition, we need this idea. Now, what will be our expression? Tan inverse. This is 1 plus A1. So you put D in terms of A2 and A1. So A2 minus A1. What is D in terms of A2 and A3? So A3 minus A2. And finally, tan inverse 1 plus A suffix n minus 1. This is An minus 1. So this is value of D. Now this is compact formula. We know tan inverse x minus tan inverse y. So tan inverse x minus y by 1 plus xy. So this is result of inverse circular function. So we are given this compact form. So it can be written as tan inverse A2 minus tan inverse A1. Second one, tan inverse A3 minus tan inverse A2. And last one, tan inverse An, tan inverse An minus 1. Now look, there will be a pattern of getting the terms. This is A2 minus A1, A3 minus A2, A4 minus A3 and so on. Look, tan inverse A2 is cancelled out. And if you take here, it will be tan inverse A4 minus A3. So this one also cancel out. So there are n number of terms. If you take all terms, you see this term also cancel out. So only there will be two terms. That is the last one, tan inverse A1 minus tan inverse An. This one minus tan inverse A1. So this term will be cancelled. If we consider the previous term, what will be the previous term? Tan inverse An minus 1 minus tan inverse An minus 2. So this cancel out. So you are getting only two terms. Now only two terms. So if we simplify it, we get An minus A1 by 1 plus an into a1. So tan inverse. What is n? Nth term. a1 plus n minus 1 into b minus a1 by 1 plus n. Now finally you are getting n minus 1 into d by 1 plus an a1. So this will be our final answer. Now, so if there are 3 terms a1, a2, a3, then put n equals to 3. What will be the value? 2d by 1 plus a1, a3. So this is problem of Wbjee for 3 terms, and it is general. You can put suitable value of n and you get different problems. So this is most important problem. Now we consider 2 problems of JEE Main of 2022. These are problems of JEE Main. So same type of problems. Now consider problem number 2. Quote inverse. This is not quote inverse, I think this is quote. Quote n equals to 1 to 5 tan inverse 1 plus n square equals. So we take this term. So suppose tan inverse 1 by 1 plus n square. Now I have already discussed. I will use this formula in each case. So tan inverse x minus tan inverse y. This will be 1. So this is, suppose this is Tn. So our main aim to express Tn as a difference of 2 tan inverse. So this is 1 plus xy. So we can write n common n plus 1. And for this one we can write it as n plus 1 minus n. So this is equal to tan inverse n plus 1 minus tan inverse n. So this to be noted. This to be noted. Now here you have to find sum of n equals to 1 to 5. That is T1 plus T2 plus T3 plus T4 plus T5. So you are getting, what is T1? Tan inverse two minus tan inverse 1. Tan inverse 3 minus tan inverse 2. Tan inverse 4 minus tan inverse 3. Tan inverse 5 minus tan inverse 6. Tan inverse, so this is T1, this is T2, this is T3. T4 is tan inverse 5 minus tan inverse 4. And what is T5? Tan inverse 6 minus tan inverse 5. So this is sum up to 1 to n. So look, tan inverse 2 cancel. Tan inverse 3 cancel. Tan inverse 4 cancel. Tan inverse 5. And we have already stated. So you have to remember, you get only 2 terms. Putting n equals to last term. What is last term? 5. So tan inverse 6 minus tan inverse 1. Putting n equals to greatest term, that is 5, and lowest tan inverse 1. Now, if we simplify, this will be tan inverse 6 minus 1 by 1 plus 6. So tan inverse 5 by 7. Tan inverse 5 by 7. So what is our expression? Cot. And we have calculated up to this. This is tan inverse 5 by 7. So cot inverse 7 by 5. So we are getting 7 by 5. So value equals to 7 by 5. Now what is your shortcut rule? Shortcut rule, this one. So if you get Tn, put n equals to greatest value minus n equals to least value. N equals to least value. Now third one, exactly same that of previous. So look Tn, tan inverse. We are taking this as Tn, not Tn. This is Tr. So r square plus 3r plus 3. So our main aim is to express it as a 2 tan. So r square plus 3r plus 2, and this is 1. We must take here 1 plus x into y. So express it as a product of 2 terms. So 1 by 1 plus, this is r plus 1 and r plus 2. If you factorize this, you get this one. And this one is tan inverse r plus 2 minus r plus 1 by 1 plus r plus 2 r plus 1. So finally you are getting tan inverse r plus 2 minus tan inverse r plus 1. So this is our main aim, to express it as a difference of 2 tan inverse. Now this is Tr. Now what is Sn? Sn equals to summation Tr. R equals to 1 to n. So I have already discussed it. It will be obtained by putting r equals to greatest value minus r equals to least value. This is Sn. So limit n tends to infinity Sn, that is n is replaced by infinity. So tan inverse infinity minus tan inverse 2. So tan inverse infinity is 5 by 2. So 5 by 2 minus tan inverse 2. So now this is PART inverse. So finally n tends to infinity, so this is PART inverse 2. Now look at our result. So this is 6 multiplied by 6. 6 into tan, and we know the value of n tends to infinity. This is PART inverse 2. So 6 tan of tan inverse half. So 6 into half, this is 3. So answer will be 3. So this to be noted. So express here in terms of difference of 2 tan inverse. Find Sn, sum of 2 n terms. So you always remember it will be obtained by putting highest value minus lowest value. Then if it is sum up to infinity, put n equals to infinity. Now to be noted here 6 is given, so it is multiplied by 6. Now same type of problem. Now we consider problem of JEE Main 2020 and it is also problem of IIT. So same type of problem we look. Cot inverse A equals to cot inverse 2, cot inverse 2 into 2 square, cot inverse 2 into 3 square. So you look this one. So we can write it 1 into 2, 2 into 2 square, 2 into 2 square, 3 into 2 square. No, this is not the case. So 2 into 3 square, 18. 18. 1, 2 into 2 square, 8. Okay. 2 into 2 square. And this is 2 into 1 square. So 2, this is 8. Okay. So cot inverse 2 into n square. N equals to 1, n equals to 2, n equals to 3. So if you take, so suppose this is n equals to 1, 2, n. So this is k equals to, so 2k square, 2k square. That is sum up to k terms. We are taking k terms. Here infinite number of terms, so we are taking k terms. Then it is not cot inverse A. So if we take cot inverse A, if it is up to n terms. So you have to write it Tn equals to, so write Sn equals to k equals to 1 to s. So what is Tk? Tk is cot inverse 2k square. Now look, this is Sn, sum up to n terms. Now what is our kth term? This one. So this is tan inverse 1 by 2k square. This is tan inverse 1 by 2k square. So you multiply it by 2, so 2 by 4k square. So I will show the step why we are multiplying it by 2. So look, in case of tan, you know there is a 1 plus 4k square minus 1, and this is 2. So meaning tan inverse 1 plus 2k minus 1, this is 2k plus, and this one is tan inverse 2k plus 1 minus 2k minus 1 by 2k minus 1, 2k plus 1. So this step to be noted. So this is our main name, cot inverse. So tan inverse as it. And we are multiplying by 2. Why we are multiplying by 2? Because difference of this is 2. And this is our main name, tan inverse 2k plus 1 minus tan inverse 2k minus 1. So this is Tk. So this step is the most important step. So what is Sn? Sn is sum of n terms. So Tk, k equals to 1 to n, this is Tk. And what is your rule? Put n equals to k, and here n equals to 1. So tan inverse 2k plus 1 minus tan inverse 2 minus 1 is 1. Now, what is cot inverse A? Cot inverse A equals to limit n tends to infinity Sn. So this is tan inverse infinity minus tan inverse 1. So this is pi by 2 minus pi by 4. So this is pi by 4. Cot inverse A equals to tan inverse infinity. So pi by 2 minus, or we can write it pi by 2 minus tan inverse 1. Tan inverse 2k minus 1. 2k plus 1. So 2k plus 1 and 2k minus 1. So pi by 2 minus tan inverse 1. That is cot inverse 1. Cot inverse 1. Cot inverse 1. Pi by 2 minus tan inverse 1. Because LHS is in terms of cot inverse. So what is A? A equals to 1. A equals to 1. So B is our answer, final answer. Sometimes problem is given in this form. A equals to this 100. Now what is A? A equals to, if you pi by 2 minus tan inverse 1. So A equals to pi by 4. But here we have to find cot inverse. So this is cot inverse 1. So cot inverse 1, cot inverse 1. Absorb and you get A equals to 1. Next problem. Now one more most important problem of competitive exam. Sk equals to r equals to 1 to k tan inverse 6 to the power r by 2 to the power 2r plus 1 3 to the power 2r plus 1. Find sum up to infinity. So exactly same problem. So look, our main aim will be to put this term as 1. So 1 plus 3 by 2 whole to the power 2r plus 1 6 to the power r by 2 to the power 2r plus 1. So to make it 1. Now tan inverse. So this is 3 to the power r into 2 to the power r by, this is 2 to the power r into 2 to the power r, and here it is half, I think half, and this is 1 plus 1 plus 3 by 2 whole to the power r, 3 by 2 whole to the power r plus 1. Now this one is cancelled out. Now this is x and this is y. So x minus y. X means 3 by 2 whole to the power r plus 1. Back calculation, we are taking this one. So 3 by 2 whole to the power r common. So 3 by 2 minus 1. So 3 by 2 whole to the power r into half. So we are getting this one. So it can be written as tan inverse 3 by 2 whole to the power r plus 1 minus 3 by 2 whole to the power r 1 plus 3 by 2 whole to the power r plus 1 3 by 2 whole to So this step to be noted. This is difficult one. So difference of these two, you are getting half into 3 by 2 whole to the power. Now it is simple. This is tan inverse 3 by 2 whole to the power r plus 1 minus tan inverse 3 by 2 whole to the power r. So summation. Now what is Sk? So put r equals to k. So tan inverse. So r equals to k. So Sk equals to 3 by 2 whole to the power k plus 1 minus tan inverse 3 by 2 whole to the power k. We are getting this one. 3 by 2 whole to the power k plus 1 minus k plus 1 and r equals to 1. R equals to 1. Now you have to find limit n tends to infinity, limit not n, this is k tends to infinity. K tends to infinity. Now you have to find limit k tends to infinity. Sk. Now limit k tends to infinity Sk equals to, it is greater than 1. So if it is greater than 1, so x to the power n tends to infinity if x greater than 1 as n tends to infinity. We have a result of limit. Now 3 by 2 is greater than 1. If we take k tends to infinity, so it will be tan inverse infinity and minus tan inverse 3 by 2. So this is pi by 2 minus tan inverse 3 by 2, that is cot inverse 3 by 2. So cot inverse 3 by 2 is final answer, or you can write it tan inverse 2 by 3. Now this step to be noted. Why it is infinity? 3 by 2, this is greater than 1. So as k tends to infinity, this is 3 by 2 to the power infinity, that is why it is infinity. So final answer is cot inverse 3 by 2. So all the problems, problem number 2, 3, 4, 5, they are of same type and most important, amazing problems of inverse circular function. So today I have discussed some similar like problem of infinite series of using idea of inverse circular functions. So you practice these type of problems. I have already solved different kind of problems. So 4 classes for competitive exam, and I have already solved typical problems, 3 classes of inverse circular functions, and board problems there are 5 or 6 classes. So thank you.